In this video, I will show how to use the measure area screen. So the measure area screen is that yellow window that looks very much like the fitting screen, which is the blue window. Okay, so when you open the measure area screen, you get those vertical lines, two vertical lines. Sometimes those vertical lines seem hidden, but they're actually on the side, and you can see the text box, just as so. Okay, so you just have to make sure you have them. And then I will show how to use it using a sample, which is the PET sample shown here. So in here, I've got the carbon 1s, the oxygen 1s, and a survey. So to measure an area, you would open the screen and simply move to the desired position. So somewhere around here. And now you can choose the methods you would want to create the background with. It could be a multi-region smart, which is a Shirley background if the background goes up, a negative. If the background goes down, it's a linear background. And then we can choose between Shirley, linear, or Tuga, U4 Tuga, or the simple U2 Tuga, which has been recently added. So now, if you move those regions, for example, like that, you will see that the area name is changing. And if I open my core level list, those are the list of possibilities that I have at that position. I can press Control, and then those two lines should move at the same time. The first time it may not work, so I'm unpressing Control, then repressing Control, and now you can see that I can go in between and just check what's coming. So here there will be no carbon 1s. This is more osmium and maybe close to ruthenium. And we have a distance between the center of the binding energy and the possibilities, really. But let's continue on to our carbon 1s. So to measure the area, we'll take all those things. This may be on PET, it may be the pi star. And we have as probability carbon 1s. If you don't get what you want, you may just select it here, it's changing, or you may rename it as you like. So let's create the background. Now you get these values. The values is shown here. And this was done with a Shirley. You could decide to do it with a Tuga, which I would recommend to do, and especially a U2 Tuga. And if I do it, I get the standard shape of the U2 Tuga. The U2 Tuga is a Tuga with only two terms, and the C term is always at 1643, and the B term shown here, but it's not this one, it's actually recalculated so that the maximum intensity at this line is equal to the background. Okay, so now we've measured the area on whatever. If we change again, if we decide that actually it goes up to here, and let's make sure we have carbon 1s. If we recreate the background, then this is changing. Okay, so we can do the same with oxygen 1s, which is shown here. And we may not choose those ones. We may just go up to this value here. And we just check, is it oxygen 1s? Yes. And you see he hasn't updated yet. This is still on the carbon 1s. So I can move it and make sure that it's available. So now we have palladium or Sb3d, but most likely is the oxygen 1s. So we create the background and maybe slightly further. So we get slightly more area. And now we would, to get a results of area, we would export it into the results grid, which is just down below. So all you do is you go on this button to export, and you get this oxygen 1s added, as you can see. And if I do the same for carbon 1s, which is here, I'll add it. And now we have a results here. So the results that we find for PET using core level is around 26.6 on 73.4. Okay, so maybe it's true that maybe we've added more oxygen, carbon 1s, maybe we didn't add enough oxygen 1s as we can see from here. So we can change that. Let's do it again. So let's just remove everything. Let's redo this one. So we have oxygen 1s. Let's take the U2 Tuga again and maybe slightly more somewhere, so it goes slightly more as you can see. And now we come to an area of 41. Let's go about carbon 1s in this level. And we have, yeah, that sounds about right. So let's try again. Let's add the oxygen 1s. And now we come to something like 73 to 26. Okay, so what is the PET made of? And the PET is this chemical formula, and we have 10 atoms of carbon and 4 atoms of oxygen. And if we look at the atomic concentration, 10 on 4 will give us 71.5, 28.5. So that's what we get in here. Okay, so now let's have a look if we were to use a survey, because the measure area is much better when we use it for survey. So when we use it for survey, we can again create now, and I will just move that away, create now a new line. So let's make sure we have our line using the control. That's it. So now we are happy with this. We create the oxygen 1s, and we can see that something not quite right happened here. So I may just redo it again. Maybe actually I will zoom. As we can see, this is not what we wanted. So let's redo it. This is the multi-region smart. So the background wasn't done correctly. As you can see, this would be something like this we would want for surely. So we can't really go to somewhere like this because it will give us a weird shape. But if we were into U2 Tuga, that will be quite a nice looking shape, and maybe more something like that. Okay, so this will be our oxygen 1s. Then we can quickly go into our carbon 1s, maybe also use the U2 Tuga, and we just check what we have. And this is not carbon 1s. This is actually H3 3p, so we choose carbon 1s, we just add it together, and now we have the two areas. And we can also put it to the results grid. So when we do this, obviously now we have core levels in the results grid, and we have surveys, and we can just untick those ones, and now we check our value. So this is 73 and 26.6, which is very similar to this 73 and 26.7. So we are happy with the results. This is the core levels value give us very similar to the survey values, and there is a slight discrepancy here, which may be due to the amount of carbon that are the surface of our PET. Okay, so this is possible. Now, the other things that is available using this measure area is we can obviously switch in between different regions like so. Let me just redo it again, because as I said, maybe it wasn't done right. Yeah, okay. So now we have our vertical line, so we can go in between like this using the regions. That's also possible. That's maybe easy to see if I create a new one. Let me just go and create a new one, and I'll call this one the oxygen KLL. and create the background. So now you see, and that may be the wrong one again. So let's make sure we do that right. And again, oxygen KLL. And that's it. So now we can really switch in between and we can use the tab key. Another thing that is available here is the automatic identification. So let me remove everything that we found and let's use the automatic identification. We open this and this is actually this button shown here. So that will somehow automatically identify each pix. It's in beta versions for now, but when we do it, he found 3 pix. So if we click on it, he found the carbon 1s, he found the oxygen 1s, and he found the oxygen KLL. He's got some issues to find the carbon KLL. Let me tell him that there is carbon KLL. Maybe he will see it. No, it does not see it. So that may be something I didn't add in it, but we have those picks, so that may be the oxygen 2s. So if I tell him we have oxygen mainly, then he will look and just label those ones as oxygen 2s, and then we have a better identification of those ones. So now what we can do with this is we can basically remove some of them here by pressing enter, and maybe I'll remove those ones on those ones and just create new areas. So now we will try to create new areas using this, and you can see that now those Shirley backgrounds have been created, maybe sometimes poorly. And in the future, I think I will use the U2 backgrounds to create an area, but even this one has been created. Okay, and it may be slightly wrong, but you can use the tab as we did before to improve this. You can also now create labels, and just those 3 have been labeled. We may decide to also add this one, and maybe, yeah, that's it. We may just now create labels for that, and that is it. This is all available using the measure area.